Smokeless Chimney, Optical Workbench, Precision Emitter and Sensor. The Precision Emitter. This is the optical workbench laid out on a table. Precision emitter on the right, sensor on the left, brains, microcontroller on the lower left, DC to DC converter in the center, lower, and battery pack. Everything is running on the battery pack right now. There is a relay on the brain controller that is turning on and off the light. The precision emitter is a light source that, when made with white filament, will glow. A good characteristic. The data coming off the serial port indicates that we have good resolution on the opacity numbers. We have light transmission of 99.92 and an opacity of 0.08. These are the renderings from Fusion 360. They are much cleaner than my workbench, but it shows the parts, the components that were made. And this is how you would calibrate an optical system. You would put reference filters within the light beam to calibrate the opacity values on the sensor. Fusion 360 has great rendering capabilities, and all the parts that you see here are 3D printed or manufactured in some way here in the Smokeless Chimney facility. Here is a rendering of the octo-ring optical system as we envision it in the field. On a chimney, this would be 4 inches tall, 100 millimeters. Not too obtrusive. This is a view down the axis of the optical system, so you're seeing right through the chimney here. And I'll remove some more of the shields so that you can see some of the parts on the inside. Here, the optical system, the black square on the left going through, but you also see some other things that have green fans on them, and I'll get into that really soon. This device would be autonomous, self-powered, and the green fans are the power generation unit. This is a close-up rendering of the green fan. The green fan moves air over some fins, and the heat pipes take the heat away from some thermal TEGs, or thermal electric generators. The heat is needed to be removed, and the fan and heat pipes appear to be the best way to accomplish this. These are some renderings from the design process where we fabricated these parts, and you can see that there's some impressive technology here. It's all well and good until you actually make something, and this is how they actually look. They look a little different than the renderings, but the dimensions are the same, and they appear to work very well. This is the heat pipes on the underside that are pressed up against the cold face of the thermoelectric generators 2 thermoelectric generators, 40 by 40, will fit under here, and then it is squished in some paste onto the hot surface. A little glamour shot with the light moving around. It's all very photogenic until you install it on the appliance, and then it gets rather cluttered. But here they are. They do fit, and everything is mounted up. The fan is installed, an 18650 battery, and some electronics. So the way you measure opacity is you have a precision emitter on the left, and it goes through some light ports and your media and comes out the other side slightly different, a little less light and a slight change in color on the light, and it's received by a sensor which is shown as a green eyeball on the right. So now you have the essentials of opacity measurement: a precision light source, a digital sensor, media, and calibration filters. All can be tested on this precision workbench. The value here is that we can measure smoke by opacity measurement. It's a time-tested method for measuring smoke and can be used to control a combustion process such as a wood stove, biomass burner, or other industrial or residential heating systems. To conserve power, we turn the light off. Here's the precision emitter light source turned on. Smokeless Chimney, warm homes and clean air for everyone. www.smokelesschimney.com